That too. Thanks to the organizers for putting the conference together, and thanks for the invitation to tell you this story. This is a story, in a sense, about one particular sampling method, about river sampling, but I think it's also a bigger story about methodological innovation in survey research and claims made and empirical testing of those claims. So let's see, I assume this is what I do. Okay, so we're going to start with 2016. As you remember, a very happy year for survey research when 538 and the New York Times had projected that Hillary Clinton had huge chances of winning the presidential election based upon an aggregation of surveys, which of course did not happen. And after that, APOR put together a task force to evaluate what went wrong. And they identified three sources of error. The first, real change in voters' opinions as the days moved toward the election after the polls had been done. Secondly, overrepresentation of college graduates in the samples without proper weighting. And lastly, the shy Trump phenomena that you see listed there. I want to propose another explanation today that wasn't acknowledged in that report that has to do with mode and sampling. And this is Venn diagram. I guess you can think of it just as a frequency plotting of the modes and sampling methods that were used for the studies included in those kinds of meta-analyses. And can I point with this? No, I can't. Okay. You see on the right-hand side, the largest set of these pre-election surveys were done with river sampling. And I'll tell you what river sampling is just in a second. But at the very bottom there, that cute little red slice is random digit dialing. That's probability sample with live interviewers. The green slice at the bottom for entertainment purposes is these are samples drawn from lists of people who have driver's licenses. But the dominant force in all of this is river sampling. And the river sampling in that year came from two primary sources, Google Consumer Surveys and SurveyMonkey. And so Google Consumer Surveys launched itself proudly like this. And the way they efficiently, this is a brilliant idea really for collecting survey data efficiently. The idea was at the moment that it was launched, the news media were cratering in terms of income. And so the question was, how could there be a coming together of a market for survey data and a way to rescue the news organizations? And the proposal was that if you started to read a news story at the Toledo Blade newspaper, that after a paragraph or two, a box like this would pop up and it would say, answer this question, and then you can read the rest of the story for free. And the answer to the question was monetizable. So it was free to the reader, but Google could then sell the answer to that question and give a little bit of money to the Toledo Blade. So it seemed like win-win all around. And you can see at the bottom here that according to Google, users complete survey questions in order to access high quality content around the web, and publishers get paid a portion for the users. And so that led to proud announcements like this. And the important part of this announcement is circled in red, that this method was said from its very beginning to be fast, accurate, and affordable. Somebody has probably told you already that you can't have all three of those things in life, but in this case, they claimed that you could. And SurveyMonkey operated a little bit differently. You know that SurveyMonkey started off as a very successful online platform for questionnaire administration that was made available free. And so if you were running the PTA meeting on Tuesday and you wanted to know where did people want to buy the pizza from, you could put up a little SurveyMonkey survey. And their claim was that millions of people were using that platform all the time, lots of different kinds of people, PTAs, sports teams, moms running baking clubs. And, you know, why wouldn't it be the case that if at the end of those surveys, there happened to be another question, who are you going to vote for in the election on Tuesday, we could get huge, and yes, huge, geographically distributed, yes, geographically distributed samples of people who would answer questions. And so again, if you think about these two methods, they're called river sampling because people are sort of swimming along in the river, either reading news stories or they're answering the pizza survey, and then they get intercepted just for a second with this little quick question. Let's talk about the accuracy of this method. And to set the stage for you, I'm going to tell you about the accuracy of other methods first, just to put it in context. This is a paper published by David Yeager et al. In 2011. I think you saw a reference to that earlier today. Just as a little footnote, if you don't know what's happened to David Yeager since he published this paper, you should check, because he's become a superstar, rock star of social science at the University of Texas, Austin. And this, what you can see on the left-hand side here is that in this particular study that administered the same questionnaire through various different methods, that random digit dialing telephone and probability sample internet data collection for a wide variety of measures that were benchmarkable against accurate assessments. For example, the government tells us how many people have a driver's license. You could compare that here. The average error for those two types of probability samples was about 3 percentage points on average. And to the right, what you see for 1 through 7, these are non-probability opt-in companies. And you can see that the average errors are higher and sometimes considerably higher. So just to quickly show you what a graph looks like to compare it to something I'll show you later, these are the distributions of the errors. And so what we want is for these bars to be very tall and to the left, to be close to 0, like hardly any big errors at all. And what you can see is that the telephone survey had errors ranging up to 9 percentage points, that the probability sample internet surveys had errors ranging up to 6 percentage points, and the non-probability opt-in panels over on the right had considerably larger errors going up to 17 percentage points. Okay, that's old news. Here's the new study. The new study involved, again, identical questionnaires, one from benchmarks from government surveys and the other public opinion about global warming. And you'll see what we'll do with that in a minute. For each of a series of different data collection firms, we had 1,000 respondents. And the samples came from 15 telephone random digit dial probability samples, 2 different firms doing internet probability samples, 7 opt-in panels to start with, and then this internet river sampling. That's the focus of comparison. So the first stuff that you see up there is, in a sense, a replication of what I showed you from Yeager before. But in this case, there's a much, much larger group of benchmarks. The benchmarks come from face-to-face surveys with response rates in excess of 80%. And these are the surveys. I won't read them all out loud, but we love and know all of those. And so lots of different kinds of questions, 25 in total. They'll just give you a quick example of some from the American Housing Survey. I won't read these out loud, but they involve air conditioners and fire extinguishers and kitchen sinks and repairs and maintenance and things of that sort. Lots of different kinds of topics. And we're looking here at average absolute error. And along the bottom, now this is like that figure I showed you before, the probability samples over on the left-hand side. This is only the internet now. We're holding mode constant, and the opt-in samples to the right. And interestingly, the 2 probability sample average errors for this set are kind of averaging around 4 percentage points, so kind of a little higher than what we saw before. But what you can see here is that when you look at the opt-in samples, the average errors are all larger. And what I'm going to show you next is whether post-stratification weighting helps. So I'm going to show you now a set of red bars. In theory, they should all be lower. And it's a little bit lower for that probability sample, and it's a little bit lower for that probability sample. But it doesn't help the non-probability samples, notably, except the really awful one, which it is somewhat helpful, but it doesn't solve the problem. So we're walking away from this figure with the same story we saw before. Probability samples do better than the opt-ins. And the question is, given these conclusions, if the average error for the probability sample is about 3.8 percentage points, the average error for the opt-ins is 5.1. What happens with the river sampling? And here's what happens. So this is the same figure you just saw, but now the river sample is going to be on the right. What do you want to predict? Remember, that's the big slice of the pie that you saw earlier. It's the worst. And more importantly, again, this is a slightly different set of benchmarks, but what happens to weighting of the river sample? And the answer is, oops, sorry. How did we got to go through the whole thing again. I got to show it to you. Here we go. Sorry. How do I go back? There we are. Yeah, it makes it even worse. So river sampling is clearly the loser, and post-stratification is not the solution. And, you know, just to state the obvious to all of us, post-stratification is, you know, like on that set of variables that you post-stratify on, and there's no guarantees that they're strongly enough correlated with the other 25 benchmarks in the right directions that it'll really work. But it turns out that there's more than that. I don't need to repeat these conclusions. Let's actually look for a second at why the weighting is worse. Why does it make it worse? And the answer is because, first of all, they're using very few demographics, but more importantly, they don't measure these demographics. They guess what they are. So they don't have the respondent's sex or age or income or region, because when you're like reading that news story, they can't say, who are you going to vote for on Tuesday now? How old are you? Where do you live? And so on. So how do they guess it? Well, they guess your region from the IP address of your computer at the time of completing the survey. So we all live in Washington, D.C. right now, according to that. But more importantly, sex, age, and income come from double-click cookies that are stored on your computer, recording the web pages that you visit. And so it turns out you can see what your demographics are according to that method. And just for your entertainment, I'm a 72-year-old female. So I'm wondering what am I looking at that they're looking at? But so there's what we did was actually did river sampling surveys where we asked the respondents what their sex, age, and income and region were. And what we see for sex, first of all, is that the double-click cookies were not horrible. They're guessing correctly 77% of people. 10% of people who were females were guessed to be males, and 13% of people who were males were guessed to be females. That for age, there were 6 age categories that we look at. Only 40% of people were in the correct age category. Now, typically they were off by like only one. So if you're like 18 to 24, you might be in the 25 to 35 category. But people guessed to be older than age 65 were actually from all age categories equally. So not quite clear what's happening there. For income, we looked at 3 categories: less than 50,000, 75,000 to 100,000, and 100,000 or more. And I'm just going to show you that for the low income people, 72% were correct. For the high income people, almost nobody was correct. And what's interesting here is that the truth was that 67% of the sample had an income of less than $75,000 a year, but 95% of the sample was guessed to have an income that low. So in other words, there were people who were wealthier, but Google consumer surveys didn't think so. So, okay, on region, they did much better, 90% accurate. Sorry, I went too quickly there. So the demographics are guessed, and maybe it's not a surprise that that doesn't help, it actually hurts. Okay, but that's not the bad news yet. You thought that was the bad news. Here's the really bad news. This is the other questionnaire I told you about, which is opinions on global warming. So it's a huge number of questions, 163 questions on global warming. And you say, well, how do you do that? Well, you distribute that across lots of these Google consumer surveys and so on. And you can get those. Same time period, same questions as probability sample. Now, we don't know the truth. There's no benchmark of the truth on this. So all I'm going to do is tell you how different would your results be from Google consumer surveys as compared to from a probability sample. And we would like the answer to be 0. The answer is never 0. And this is basically a histogram. This is how many items had, and I'm sorry, I wish I knew how to point with this thing. Is this it? Ah, here we go. This is how big the discrepancy was, the absolute value of the discrepancy. So let's say we ask, do you think the Earth has been warming over the last 100 years or not? We get some percentage in the probability sample, some percentage from Google consumer surveys, subtract the 2, take the absolute value, average all those. So there are errors as big, or as big as 26 percentage points. So if you don't mind being off by 26 percentage points in your surveys, this is fine. But in general, these errors are not clustered down around 0. These are not post-stratified. When we do the post-stratification, the picture is no different. So it doesn't help. So that's big differences. But it turns out when you ask 163 questions, you can cherry pick if you want to. If you are Google consumer surveys, you can say, oh, we're great. Look at how great we are. So these are the probability sample estimates. This is just a series of questions, including income and asthma and so on. These are what the probability sample says. This is what the river sample says. Just look across. They're pretty darn close. That's fantastic. On the other hand, we could cherry pick some awful ones. So 42 versus 19, 68 versus 40, 63 versus 39, 84 versus 60, and so on. So you could make claims that it works well if you're willing to cherry pick. Okay, so this brings us now to the 2016 US presidential election. I told you that there was a swamping of the data from river samples. And when we actually went and gathered up all the surveys done during the last 7 days before the election and looked at the methods that were used and the average errors. The average error for the RDD telephone surveys done in states was 1.96 percentage points. The average error for the river samples was 4.38 percentage points. And more importantly, the only way that 538 and the New York Times were going to correctly call the winner of the election is state by state with a focus on the battleground states, right? Those are the only states that we care about. We have to know that. In the battleground states, in the data collection we were able to put together, there were 72 pre-election polls. One of them was a probability sample. The rest of them were river sampling. And it's because river sampling is really cheap. So you can do lots of them in state by state. So there really was no possibility of doing well with that. So conclusions, and the punchline is coming. Probability samples did very nicely. The opt-in panels did less well. The river sampling was the least good. And you can't really read this, I guess. But this is Google's announcement that in November, a couple of months ago, they retired Google consumer surveys. So eventually truth wins out, but sometimes it takes a long time and a lot of money was made in the meantime. Thank you very much.